welcome everybody. I guess we'll get started. My name is Todd. We've got Tyler and Zill, and we're three SaltStack users, and we're presenting to you some of our experiences with Salt, some of the problems we've solved, and if you could please wait until the end so we can get through all of our presentations, and then we'll answer questions at the end. All right. We'll start with me, empowering developers with ChatOps. Who am I? I work for a company called Riskalyze. I'm the director of data center and DevOps. Somebody at my company thought that DevOps was not a clear-termed people, so they decided, oh, well, if we put DevOps in the title, now they'll understand. So, Riskalyze, there's a big, long statement of what we do, but basically what we've done is we've taken the vague concept of a moderately aggressive investor, which, how do you understand, how do you know what that means? Everybody has a different definition, and we've turned that into a quantitative risk number. Here's my tolerance for risk, and then here's my portfolio's risk number, and then you can compare them and easily see, are you invested correctly? So there's my brief plug. So Riskalyze is about 3 years. I've been at Riskalyze about 3 years. We started out as Agile, started out as DevOps, started out as fully cloud-based, unless you count our one Raspberry Pi in the office. Big server farm at the office. So the problems that we have come across that we're presenting the solution for today, we always use SaltStack for our AWS servers. And since we're Agile, we have lots of features, multiple features a day, and unfortunately way too many hot fixes per day. We've been having rapid growth. We have doubling of engineers. When I started, there were 7, and 3 years later, we're in the 50-some-odd range. So a lot more engineers means more hot fixes, more features, and we want to do testing of features in a production-like environment, which means in AWS. QA wants to QA in a production-like environment, which means AWS. And so that means I'm getting asked a lot, can you please create me some servers in AWS? So here's the solutions that we pondered and looked at. Local test environment, that's obviously always going to be used, but a local test environment's never going to really match to your production environment, so we're always going to want to do testing in a server environment. Standing test servers that developers share, fight over, and manually update. Anybody do this in their companies? We did this for a long time, and there was a fair amount of fighting when there's 3 servers, or 3 test environments, and 5 people want to test. So that really didn't work for us. Operations team keep creating servers and waiting, and developers waiting patiently when ops is busy. Generally, ops being busy with something else that the developers are asking for. That one didn't go over so well. Developers learning to use SaltStack directly. That is a solution we looked at, but if we have 50 people and we want to teach all 50 how to use SaltStack, that didn't seem like the best solution. And so, as you can tell from the last one, what our decision was is, how can we empower developers? And we decided to empower them with ChatOps. If you're not familiar with ChatOps, it's basically the idea that within your chat solution, you have a bot that's listening and responding to messages that are sent there. Our ChatOps solution was Slack and Hubot. SaltStack that's actually processing them, that's ChatOps. So what we decided to do was we're going to start very simple. We started with CRUD, database terminology, but we put it here, create, update, and delete servers. At the beginning, we had one Salt for both dev and production, so obviously having some security checks so that developers could not add or delete servers in production was something we wanted. We've since split it so we have dedicated Salt environments, but we still wanted that security check, so somebody from the marketing team, they're not going to be spinning up servers, so let's disable that for them. And so with that basic feature set, we said, let's send it over to the developers. Let's see what they think, and then let's get some feedback. So when we first started looking at this, this is what we saw. For the developers, it's a win because they can create a server when they want it. They don't have to wait for my ops team. And they didn't need any shell or salt experience to create the servers. All they had to know is how to run something in Slack. And since we're a Slack shop and they probably send hundreds of Slack messages a day, that seemed pretty easy. For the operations team, I really did not like to be a bottleneck to testing. If a developer is waiting on me for testing, they're more likely going to decide to not test. So let's get ops out of the way for that. Obviously, less grunt work for the ops team. We don't have to be spinning up servers every time they are asking for them. Plus, it allowed us to put some guardrails. You know, one guardrail is who could spin up servers, what size of servers. I don't want somebody spinning up a testing server on an i2 extra large and spending a lot of money on it when only, say, an M4 medium is needed. So that was our win-win. Is anybody familiar with CoffeeScript? Seen it before? I believe that when Hubot was created, CoffeeScript was the in thing, and so Hubot was created in CoffeeScript. So if we want to look here real briefly at the CoffeeScript, the first line there is a lovely regex that is going to match a message, and it'll only fire this script if it sees a create server with the appropriate information on it. Next line, we're going to put a restriction. I've got a function that is going to look at the user and see if they belong to a group. If they do belong to those groups, fine. Otherwise, it's the return if basically would say if they're not in one of those groups, it just errors out. All right, if we move down, you'll see towards the bottom, we've got the cloud profile. That's your Salt API command that you're going to be firing off. And the arguments of that are going to be a profile and a server name. An important thing on something like this is before we do too much, we should send a message back to the user. If you don't send something back to the user and they're waiting for minutes for that server, what do you think is going to happen? They might say, did I create it? Did something happen? Let me try it again. Let me try it a third time. And all of a sudden, you've got a lot of servers spun up. So an immediate feedback really was helpful. Of course, down here, now we've got setting some headers. We're sending the post body off to Slack. And once Slack comes back, says the server is all done, I'm going to send a message back that the server's been created. Not showing on the screen here is error handling. If the server didn't create for some reason, I'd need to send a message back saying this didn't work. So Hubot has lots of plugins, and one of the plugins was a security functionality. It has the concept of groups, and you can add people to groups right with Hubot commands. So right from Slack, I can say user X is in the developers group, and then done. Then they can use these commands. So my restrict command is then looking at those groups and saying, first, is it an admin? I made an out for myself. An admin group is a fixed group that's in the env file. Nobody can be added or removed, so it's a pretty secure group. And then if they are not in the group, it's going to send a message out saying, sorry, Charlie. So I couldn't do a demo because servers for me generally take about 10 to 15 minutes to spin up. Part of that is because build the server, then you're going to do OS updates, and then unfortunately we're using Node.jip in a lot of our NPM nodules, and Node.jip is a compiled process that takes a long time every time. But here is a screenshot of me creating a server. So 1021, I send off that command. TARS is what we called our chatbot, and it's going to come back and say, okay, I'm going to create that server. And then in my particular one, I split the creation of the server, the high state, and the deploy into 3 steps. And so it's going to notify back when each of those steps completes. So it's alive, it's being configured, and it's done. And if you haven't seen Hubot, unusual messages like this one, it's not life as you know it, that's kind of a Hubotism. There's a lot of that kind of just in ChatOps and in Hubot in particular, of putting those kind of Easter egg type things in. So Hubot help, I wanted to show some of the commands that we've expanded into. We started with just creating servers, and as you see, we've got quite a few other things that we are doing there. I'll highlight out a couple. Developers really liked being able to create the servers, and so they're, all right, I want to create my web server, my app server, my other app server, and so they're creating 3 or 4 servers. Well, do you think they want to run 3 or 4 commands? No. So they came back and said, well, how about we just run 1 command and we can create all the servers with 1 fell swoop? And that's where the create series came from. And under the scenes, it's taking that number, 314, which is the series number. It's going to take this, the pro, the workflow, the API, those are slugs to indicate what kind of server, followed by the branch that the server is on. And so Hubot is taking those things and creating 3 create server commands. And it's literally in the Hubot script, it's saying create server, etc. It's calling itself. People really like this. They're spinning up lots of series. They're doing their testing. And when they're done with their testing, they're cleaning up after themselves every time. No. We would have about every 2 weeks, we would have to go in and we'd just have to wipe out all the servers because we would have 50, 60, 70 servers sitting around that weren't being used. So we said, yeah, this isn't... Let's wait till the end time on that, just so we can make sure we get through. Hold on that. And so this was to save the developers not having to delete the servers or us having to say, hey, we're wiping everything out just because we don't know what's in use and what's not. We put in the TTL. And we put in a default TTL of, I think, 16 hours. We figure if somebody, first thing in the day, they spin it up, that'll cover a full work day. And if they know they want it longer, they can override it with the TTL command. So the results that we have had, I looked at my logs and we had 115 server series created last week. And that's in the neighborhood of about 350 servers. Developers and QA definitely have been empowered on this. If we say that there's 50 developers in QA, that means each person is on average spinning up a little over 2 series per week. So it seems like that's working for them. And testing is happening. And in that week, besides having an NPM server go offline and therefore deployments failing, I had to do nothing for that 115 servers. So it was good for my team to not have to do this, and also it's good that operations is not seen as a bottleneck anymore for people to do their dev and testing. And it allows them to ask us more important things and us to work on more important things. So what will it take to get started? Obviously you all have SaltStack. If you haven't enabled Salt API, you'd need to do that, and to create at least 1 cloud profile that the Hubot can use to create the servers. You're going to need Slack. You're going to need a Hubot with basic CoffeeScript. The basic commands for CRUD, we'll see that in just a second. And to set up some authorization groups. And like I said, if you have the authorization, you can literally say, Joe is in the QA group in Slack, and he's now in the QA group. So to add the users. And to help getting started, here's a basic in NPM, and these slides are all linked. Our slide deck is linked in the app or on the web page, so you can get it from there. And so I created a project and also an NPM module that you can use to install this into a Hubot instance, and it should allow you to at least have basic functionality working pretty well. All right, next.
Hey guys, so today I'll just be talking about our use case for Salt and how it helped us move from a managed services provider into AWS. So I'm Tyler Kudo. I've been working at Certain Inc. as a system administrator for about 2 years. Certain makes event management and automation software, which closely integrates with marketing platforms like Marketo and Eloqua. Sure.
A little closer.
Speak up. So first, a little bit about our infrastructure. We have a basic 3-tier infrastructure, web tier, app tier, and then database tier. And the thing that I want to point out and what's going to be pertinent for the rest of the presentation is that we split our application tier into pods. So you can see here that we have an ELB load balancing on this pod of application servers, and then another one over here. And then we have a common web tier and database tier. So a year ago, we were in a managed services provider. We rented hardware and paid for management of a VMware cluster. So some problems is that it's not agile. We had to create tickets to spin up new hardware, to spin up new virtual machines, to create load balancer and firewall rules. And all that stuff is also pretty prone to failure, as well as being taking a long time. We also had incomplete configuration management with some legacy CF engine, and sometimes partial config management is worse than none because you don't know what is managed. We also had some inconsistent application deployments. We were doing a lot of copying and pasting in the Bamboo UI, which led to drift across deployment scripts. So the solution was to move to the cloud, specifically to AWS, to implement comprehensive configuration management with SaltStack, and then to implement a push-button application deployment that's consistent across all services and environments. So first, let's talk about Salt for configuration management. YAML and Jinja is awesome. We store a lot of our main configuration in what's called our pod pillar, which stores the configuration variables for a single pod. And this is kind of what it looks like over here. As a stripped down version, you can see that this is our pod 2 pillar. It stores stuff like the database endpoint, and then a dictionary of portals. It has a URL, a database name, encoded user, encoded password. So we use this to configure a lot of our core services like Apache HTTPD, our Tomcat services, and some of our platform services. So here's an example of how we use it in our Tomcat configuration. And firstly, let me just say that being able to do this was super useful for us. We used to copy and paste and manually change this file, this context XML file, so being able to template it with Jinja was just awesome. So you can see here that we're gonna, this is our context XML for our Tomcat configuration. We're looping here over the portals dictionary and filling out this resource for each of these portals. Just a little bit about the hostname convention. We had the opportunity to change our hostname convention when we were moving. So first of all, just a good hostname convention is super useful to know which box that you're on when you're on there. And then also you can do easy things like this, easy targeting of pillars by splitting out your ID in environment pod and things like that. So let's talk about Salt for application deployment. Just a little recap on our architecture considerations. We are deploying to several pods. Each pod has several different types of applications, and each of these needs to be deployed in a specific order. For example, our main application consists of a certain app and then some platform services. Certain app is further split up into a certain app master, which needs to be deployed first. Then the rest of the certain apps can be deployed, and then finally our platform services. And then we do this 3 or 4 pods at a time, usually. And then a little bit of a recap of where we were trying to go. We had these shell scripts copy and pasted into the Bamboo UI, a lot of drift. And we also had separate deploy scripts for separate services, which meant that we needed to do orchestration by us. And we wanted a consistent push-button deployment orchestration across services and environments. So this is our implementation. We have a top-level orchestrations for both the deploy and download steps. And these call state files for each service. So there's a state file for each service for download and a state file for each service for deploy. And this is what we run for all of our deployments. This is how we configure it. This is our deploy pillar, which we can, so you can see that we have our environment here. We specify which pods we're deploying to, and then also which services we're deploying from. This is a snippet of our top-level deploy orchestration. You can see here that we're going to loop over the pods in deploy pods. First, we're deploying the certain app master, and then the certain app. We're going to batch it by 25%, and then we're going to call this deploy.certainapp state file. These are some highlights from the a download script, the download state file for a certain app. Not too much of a surprise here. We're going to create an artifacts directory, download some artifacts, compute some hashes. This one's a little bit weird. We're going to remove that artifacts directory. Why would you want to do that? I'll get into that just a little bit later. And this is another snippet, some highlights from the deploy step from our certain app application. Also not too much of a surprise. I'm going to skip a few of these, but basically we're going to stop Tomcat, deploy some new wars here, start Tomcat, and then wait for initialization to finish. So during our deployments, we do use ELB APIs in order to take instances out of the pool in order that we don't affect customers. So first we're going to check if the instance is registered. Sometimes our instances are not. And then if it is, we're going to remove the box from the ELB and then deploy, and then at the end we're going to add it back in. We also use failhard in our deployments, which is super useful to kind of stop the bleeding. In this case, we're waiting for Tomcat initialization to finish. And then if there's some problem, which there could be, we're going to fail hard here and make sure that we don't deploy bad code to the rest of our environment. So this is what I was talking about before, where we're going to remove the artifacts directory. We use requisites to skip downloads. We copy artifacts from San Francisco to our AWS environment in Virginia, so we want to make sure that we only do that a single time. So in order to do that, we're going to create this artifacts directory. And then in the case that it was created, we're going to start downloading artifacts. And then if there's any problems with any of the downloads, we're going to remove this artifacts directory and try again. So we do have a couple custom modules. The first is a Datadog module. We use Datadog for metrics. And we're going to schedule a downtime before deployment and then cancel it afterward in order to avoid erroneous alerts. So this is what that looks like here. You may have seen this before. We also have a loop state. This loops over execution modules. And in this case, we're going to wait for Tomcat initialization to finish. So we're going to loop over the get instance health module from Bodo ELB and wait until the condition in service is met or this timeout is reached. So did we succeed? Yeah, I think mostly. We have a comprehensive configuration management now for our core services. There's always new things to do. And we also have a push button application deployment through Salt, which is maybe a little bit more complex than it needs to be, but yeah. So the future, I'm super excited about the parallel runners feature that got pushed a while back. As you saw, we were looping over pods to do application deployment, and it'd be awesome if we could do, deploy all of them at once. And then, Salt is huge, so I'm excited about, reaching out into these other modules and figuring those out as well. So thanks. Come chat with me if you have any questions or thoughts or ideas. We're also hiring, so find me or this guy right here if you're interested.
So how many of you have used salt reactors? Okay, very good. So I'm going to talk about self-healing aspect of it and how we use salt reactors for that. So my name is Zil. I'm a DevOps engineer at Nyansa, which is a small startup in Palo Alto, California. So we primarily do analytics. We try to basically triangulate issues related to an end user by querying different access points and services within your infrastructure. So that's the gist of it. And what are some of the challenges and why we're using salt reactors? Of course, to reduce cost because we're a very small startup and we're very conscious about cost. And we also needed to support multiple providers for our both public and private cloud. And we also want to encourage developers to add to the infrastructure code. And of course, improving the resiliency that salt reactors can provide for us. So this is our typical use case. We have our staging and development environments are on Spot instances. For those of you that are not, how many are you familiar with Spot instances and how they work? So basically they're 1/3 the cost of a regular instance. And AWS can just take away at any time, they want. And what we basically do is so AWS lets you know when that instance is going to go down. So you have at most, I believe, 2 minutes to do anything that you want to before it goes away. So in this case, we have a typical environment that has a green, blue, and purple cluster. They're all minions, of course. And then on the box above is a salt master that has associated what are called reactors, which are threads or processes that are listening on the salt event bus for something that may or may not occur. Okay? So a node goes down. The virtual machine or the node itself sends a message to the Salt Master server, and this is what the message looks like. You have a tag ID that tells the Salt Master that this is what the cluster ID is. In this case, is staging. And then within the payload, there are various attributes, including IP address, instance type, and so on. And then the salt reactor intercepts that message. It basically parses it. It performs some sort of a correlation logic, which I'll get into why that's important. And then it obviously recovers and validates. So there are 2 salt reactor types, for those of you that are not familiar with them. First one is the internal or the built-in ones, which are very simple to use. So you have this file where you see a tag that I showed earlier. So whenever an event is fired, that tag basically matches this reaction that's outlined here. So in this case, full log tag, when it's fired, then we basically call the cleanup logs.sls file. The second type is the external reactor, which are your custom bash shell scripts or Python scripts that you may want to reuse in your environment. So for the demo portion, what I've done is I've actually done a very basic example of how SaltStack Reactor works for both the use cases. And the demo is self-contained. I'm using Vagrant Box. So basically, you can go to this GitHub repo and spin up the environment. So without further ado, as you can see, I have a master on the top. I have 2 minions. And what I'm going to show you is obviously I've done the setup already. And in this case, I talked a little bit about the built-in reactors. In this case, cleanup.logs is a simple formula that would remove the log.txt file. So I'm going to start off with the listening on the event bus. So I'm going to open up this window and start this. And then I'm going to create this temp log.txt file. So you see that. And now I'm going to fire off my event. So this command event.send, that's going to be sent to the Salt master. And if we've done everything right, the log.txt file should disappear. And it has disappeared. And if you take a look at the event bus here, we did see that the event full logs was registered by minion 1. And the reaction was removing the log.txt file. Okay? So very straightforward. Let's get into the external reactor. So that's what we actually do for the Spot instance outages, is particularly for the Spark clusters. So in this case, I have a separate Python module, and I'm using the Salt's built-in library that listens to particular events. So I'm not going to go through the entire code in the interest of time, but I do want to highlight that in my main, I basically define a tag ID that I want to listen the events for. And then I basically spawn off a process event thread. And in my main thread, whenever I see an event, I'm going to put it in the queue so my worker can do some sort of logic. And then in my process event method, I basically implement the correlation logic or do the recovery or whatever that's needed for that matter. So let's quickly take a look at what's going on here. So on my Salt master, I'm going to do 2 things. I'm going to start off my external reactor and start tailing that demo.log file. So let's switch back here, and I'm going to clear this window. And then the second thing I'm going to do is I'm going to fire off an event from minion 1 and one event from minion 2, and which are basic dead events for this particular demo. So I'm going to paste this in here for minion 1. And then I'm going to paste this one for minion 2. And as you can see that we did receive these 2 events. Our correlation logic in this case was simple. We're just waiting for all the events to come in. And then after that, basically our recovery logic kicked in. And this is just at this point, it's just a comment that whatever complex logic that you need to implement at this point, you could call Salt Cloud, for example, to spin up the replacement instance, and then you call this a Salt State High command to provision the new instance and so on. All right. So going back, so why salt reactors? For us, we've been able to save about more than 250,000 or $250,000 in a year. So for us, that's quite a bit of money. And we primarily use it for our dev staging and POC environments. Reactors are very easy to customize, and there are extensive documentation and examples available, including the GitHub example that I provide. At this point in time, I would like to open it up for any questions that you might have for myself, Tyler, or Todd.
We can start with you in the back.
Yeah, I was asking for the DevOps demo, how do your teams define the multiple instances they need as part of a set, or what did you call them?
Yeah, we call them slugs, and basically each server, we have, like this gentleman, we have well-defined host names, and so the first section of our host name was the data center, the section was the type of server. And so in that slide, you saw 3 slugs. Pro was our pro server. API was our core API server. And so all that Salt had to do was, oh, okay, I know how to do this. Actually, all that ChatOps had to do was create a host name. And then Salt knows, based on that host name, how to spin up that server.
Okay, so when they're creating a set of servers, it's always the same type of server in that set?
No, each of those was a different kind of server.
Oh, it was.
Yeah, the pro server was our web server. The API was our core API server. Yeah, and it was the slug that said which server to implement. The size of the server was generally the same. We have the ability to create different sizes of servers, but generally for testing, we're all the same.
And in your model, the teams can't spin up new types because it would depend on like a new profile, right?
Right, because a new type of server would have to be defined. You know, what's the repo that it's pulling from? Anything special it needs? Is this Node? Is it PHP? So yeah, when they need to create a new repo, we would have to set that up. But that's a pretty quick process.
All righty. Yes?
About your Spot instances, so when you saw that an instance was going down, is it like you just go spin up a new one somewhere else, or what do you do when you?
So it really depends. When the dead event comes in, as part of the payload, we define the current instance type. So the recovery logic then has to say that the current instance type is not a good one to use. So then it might use maybe like C4 extra large or C3 extra large or your strategy might be that I'm just going to go ahead and use a reserved instance as a replacement mechanism. So that's something that you have to take care of in your reactor itself. All right, looks like it's getting close to lunchtime, huh? All right, thank you guys. Appreciate it.